All right, y'all, welcome to 2.1b. This is synthetic division of polynomials. Synthetic division is a different process that we can use in some, but not all, cases where we're dividing. So we can use this method when the divisor, that means the denominator of a fraction, is a first degree binomial. First degree meaning linear. X to the first is the highest power. Binomial meaning it has two terms with a leading coefficient of 1. So x plus 5 or x minus 2 are good divisors for synthetic division. Something like 2x minus 1 would not work because that coefficient was not 2. Something like x squared plus 3 does not work because it's not a first degree. So x plus 5 or x minus 2, basically x plus or minus any number will be allowed in the denominator for this synthetic division process. So let's look at these 4 problems and let's look at what can be done with synthetic division. If you look at that first one, the denominator is x minus 4. Yep, that can be done with synthetic division. Okay, looking at the second one, the denominator is 3x minus 7. That coefficient being 3 means no, we cannot use synthetic division. If we look at the third one, that denominator is 9x minus 1. That coefficient being 9 means no, we can't. If we look at this last one, that denominator is 2x minus 4. With that 2, we should not be able to do synthetic division. However, if we look at every single term on the top and bottom of this polynomial, it can all be divided by 2. So if we have x to the 4th minus 5x squared plus 3x minus 4 all over x minus 2, then yes, we can do synthetic division here. So it's worth looking at your factors, seeing if something will factor out. All right, let's take a look at synthetic division and how to set it up. So again, we need consecutive powers of x. So once the powers of x start, we just count down from there. So this problem starts with x to the 4th. We don't have an x to the 3rd. So this is where we need to use 0x to the 3rd. Then we have x to the 2nd, x to the 1st, and just a constant. Okay, so here's what we do. We take all of those coefficients, including the 0, and we bring them down in the first top row. Okay, we have a big L here. We have the numbers from the coefficients. We need one line underneath it, and then stuff under the L. And one of the biggest keys here is where this number on the outside comes from. And this number on the outside comes from here. That x minus 2 needs to go right here, but make yourself a really, really, really big note. You have to change the sign. Whatever the sign on the denominator was, change it. Change the sign from the denominator to the outside of this synthetic division. Change the sign. So x minus 2, we put a 2 on the outside. Now, here is our process. Here's our process. Whatever the first coefficient was, we bring it down. So we bring down this coefficient of 3. And then on this corner, we multiply. So we multiply this 3 by this 2. I did that wrong. We multiply this 2 by 3. And that answer goes up and over. 2 times 3 is 6. And then we add. 0 plus 6 is 6. There's our next value. We take this 2, multiply by 6, write the number up and over. That's 12. Then we add. And negative 8 plus 12 is positive 4. And now we multiply again. Multiply this 2 by that 4. The number goes up here. That is a positive 8. And then we add. And when we add there, we get negative 3. We do it again. Take this 2 times that negative 3. Write the answer up and over. That's negative 6. We add one more time, and that's a negative 5. Now, those numbers by themselves don't actually mean anything. But what they represent are the values and the coefficients that are in the result of the long division. So, starting on the right, the number on the right is always the remainder. The next number is always the constant, as in the number without a variable. The next one is the x coefficient, single power of x. The next would be an x squared coefficient, and the next would be an x to the third coefficient. If we had more numbers, we would keep going. So, what this means for our answer, okay, our 3 is the x to the third coefficient, 3x to the third. 6 was our x squared coefficient, so plus 6x squared. We keep going. Next was 4. That was the x coefficient, so plus 4x. Then next is minus 3. That's the constant with no variable. And then the negative 5 is the remainder. So we write it as minus 5 over what we divided by, x minus 2. And this is our final answer. So, if you're looking at that problem and you're thinking that you've seen some of those numbers before, you actually have. Go to 2.1 part A and go to example 1. Compare that to the problem we just did, and it's exactly the same problem. And if we look at this answer, it's exactly the same answer. So, being able to use synthetic division can save you a lot of steps when it can be done. Remember, synthetic division can only be done with a denominator such as x plus 5 or x minus 2. So, let's try another one. Let's look at B. We start with an x to the 5th. That's a 1. Here's our 1. We have x to the 4th. There's the 5. X to the 3rd. There's the coefficient 6. X squared. There's a -1. X. There's the 4. And a constant. There's the 29. So we have all the terms we need, all the powers we need. We took this x plus 3. It's what goes on the outside, but we change the sign. We change the sign on the outside. Okay, now we'll do the same process. We bring down the first, then we multiply and add, multiply and add, multiply and add. So start with this very first 1, bringing it down into 1. Then we multiply around this corner. So 3 times this 1 is 3. And we add in that column. So then 5 plus 3 is 8. And we multiply -3 by 8. There's a... I already tried to mess this up. Back up, back up, back up. Starting over. Sorry, y'all. Bring down this first term 1, and then we multiply and add. So we multiply -3 by 1, we get -3. Then we add 5 plus -3, or 5 minus 3, is 2. And we multiply. -3 times 2 is -6. And then we add that column. Happens to give us a 0. That's totally allowed. Then we multiply -3 by 0. We get 0. Again, 0 is a real number. It's allowed. And when we add here, we get -1. Then we multiply -3 times -1. That's a +3. And we add. And that gives us 7. Then we multiply -3 by 7. We get -21. And then we add. And we get 8. Nothing else to multiply by. We can't bring down extras. So this represents the values in our final answer. So always the far most right number is the remainder. The next is the constant, no variables. Then we have an x coefficient, x squared, x to the 3rd, x to the 4th, and these are all the coefficients. So to write that final answer, x to the 4th has a 1 coefficient. We're going to do this. 1x to the 4th plus 2x to the 3rd plus 0x squared minus 1x plus 7, then plus 8 remainder over the bottom of the fraction, x plus 3. Now, how you will normally see this written is without the 1, so just x to the 4th plus 2x to the 3rd. You're going to see that 0x squared term skipped, and it will go straight to minus x plus 7 plus 8 over x plus 3. And this is synthetic division. Now, I know which one of these two, long division and synthetic division, you probably like better, and that's all good. Remember, synthetic division can only be used in certain cases, so we are going to need to be able to do long division. All right, y'all, that's it. Bye, y'all.